Okay, time for more exponential functions. Yesterday we saw the basics and a couple of graphs of what they look like, and here we're just going to practice with evaluating them as functions, sort of with all the extra little details that they can have. So this is not going to make you break too much of a sweat. I'm going to show you 3 examples and then send you on your way to practice with similar problems on the worksheet. So you may have noticed in Google Classroom, if you've poked in there, or whoever's clicking your buttons to see this should notice this. In Google Classroom, there are 2 PDF files. One is Exponential Functions Part 1, one is Part 2. So Part 1 went with yesterday, Part 2 goes with this follow-up today, which isn't really that bad. It's just knowing a functional notation and what to do with it. So for example, 7 times 2 to the x, right? This is an exponential function. Now the basis of it is, what am I doing? I'm trying to cover the 7 on the screen by covering it on my tablet. That's not going to work. Pretend that 7 isn't there. You have 2 to the x. The base is 2 and the variable is in the exponent. That's what makes it an exponential function. The fact that we're multiplying the 2 to the x by 7 really doesn't do anything. It's still, number-wise it's going to do stuff, but it's still an exponential function. It just now has a multiple that's different than 1. That is 7 times 2 to the x, not 7.2 to the x. Okay, so we're going to look at some values of this function for different values of x, and this works the same way it always does, which is that x marks the spot. And so if you're asked for f of 1, you go plop 1 into the place that used to be x. Okay, so f of 1 is 7 times 2 to the first, which is just 7 times 2, and that's 14. Okay, f of negative 2, well, here's your negative 2, that's your x value, x marks the spot. Go into your function, go find that x, which is up in the exponent, and plop in negative 2. Now here you have to stop and process what that 2 to the negative 2 is. Remember, a negative exponent means invert. So this will actually be 1 over 2 squared, and that's 4. So this result is 7/4. And then f of 0, see, the dogs are at it. They know when I start talking. There's a dog walking by outside. That's why my dogs are barking. Maybe I'll pause for a sec. All right, we'll give this another try now. It's warm out, right? The last couple of days. So the windows are open, the front door is open so they can see out. That means they get to see everything going on outside. So they're barking more than normal. Anyway, f of 0. Go up to our function. Go find the x. Plop in a 0 for the x. So that's 7 times 2 to the 0. Here's another exponent game. You need to remember anything to the 0 power is just 1. And so that value is 7. Okay. So those are 3 sample functional values, and we could actually use these values to start doing a graph of this function. So if you remember, the graphs of these just either kind of swoop upwards or swoop downwards, like a ski jump ramp, whoosh, like that. It just depends which way it's facing. So if I try to squeeze in a very, very rough draft of this function's graph down at the bottom, well, when x is 1, the function's value needs to be 14, which would be way up there. When x is 0, the graph needs to be 7. So let's say that's 7. When x is negative 2, our function's value needs to be 7/4. That's just a little bit between 1 and 2, so that'd be smaller, way smaller than 7. And then if we play connect the dots, there's that shape we're looking for. Okay, so that's it. You don't have to graph these on this assignment. These, I'm just giving you a little bonus information there. Okay, here's a new function. We've changed the variable from x to t just to reinforce that it doesn't matter what the variable's name is. You just have to know where the spot is. So this time we have a constant multiple of negative 4 on the outside, and now instead of 3 to the t, it's 3 to the t plus 1. Okay, Doesn't matter. We do exactly the same thing. To evaluate the function at t equals 0, we are going to go to our function's recipe, and remember this time t marks the spot. So what used to be t plus 1 in the exponent is now going to be 0 plus 1. So this becomes negative 4 times 3 to the first, which is just 3. This is negative 12. That's it. For the next one, we're going to plug in negative 1 for t. So we're going to have negative 4 times 3. Here comes the t, which is now negative 1. There's the plus 1 that's hardwired into the formula. That's negative 4 times 3 to the 0. And remember, anything to the 0 power is 1. So this is negative 4 times 1, and that's just negative 4. And then finally, g of 2 is negative 4 times 3 to the 2 plus 1, which is negative 4 times 3 cubed, which is 27. So this is pretty large, but negative. Negative 4 times 27 is negative 118. 4 times 27 would be 80 plus 28, or negative 108, sorry. Like that. Okay. Again, not necessary for these, but just as something to possibly look at for later on. If I wanted a graph of this function, I would still expect the ski slope swoop kind of shape facing one way or the other. The only difference now is that this negative is going to flip it underneath the axis. And we can see that by plotting some of these points after the dog shut up. All right, so I've prepped the graph with markers on the t-axis, waiting for us to plot these points. So when t is 0, right here, the value of this function wants to be negative 12. So that's, I'll just mark that way down there without even counting off. It's far down there. I've indicated it's far down there. That's good enough for now. When t is negative 1, the value of the function wants to be negative 4. So that's going to be, you know, if this dot way down here is negative 12, negative 4 might be about there. When t is 2, for the last one, the value of our function wants to be negative 108. And I can't even draw that. That's way, way, way down there. So imagine my pen is now going way below the pencil, and it's going to come up, and it's still going to make that swoopy shape, right? There it is. But by the time it gets out to just t equals 2, it's going to be way down there. So again, it's an upside down ski slope because of that negative sign in front, but it still has that whoosh, that swoop to it. All right, I think this is the last calculational example. Again, just loading up the function with a coefficient of 1/2. The exponent isn't just the variable alone. I've put something a little bit more exciting in there. Let's fire these off. So this says, hey, go to your function. The other problem with doing this time of the day is that, you know, for me, it's evening when I'm doing this. So people are coming home and driving by. They're out walking their dogs. All right. There's all sorts of excitement out there in the streets for the dogs to bark at. I'm just going to talk over them. I don't want to pause anymore. P of 1 will be 1/2 times 4 to what used to be 2r when r is 1. That's just 4 squared. So 4 squared is 16 times 1/2. Net result is 8. Okay, P of 1/4. Well, there's our 1/2 that's hardwired into the formula. There's our 4 that's hardwired. The 2 in the exponent is hardwired. There's the variable. That's where we're going to put 1/4. If we shake that out a little bit, that'll be 1/2 times 4 raised to the 1/2. And if you remember your exponents, a fractional exponent of 1/2 is a square root. So ultimately, this ends up just being 1/2 times the square root of 4, or 1/2 times 2, and that's just 1. P of 0 will be 1/2 times 4 to the, well, 2r will become 0 when r is 0. So again, 4 to the 0, what's that going to be? 1. So 1/2 times 1. And then p of -1, just to finally get a negative number up there, we got the 1/2 in front. If we put in r equals -1, the exponent now is going to be negative, or 2 times -1, which is -2. Negative exponent means invert. So this will be 1/2 times 1 over 4 squared. And that'll be 1/2 times 1/16. Altogether, that's 1 over 32. That's a tiny number. Now, I don't have room on this page anymore, and I don't want to start flipping back and forth between pages to recapture numbers. But if you're curious, which you should be because this is fun, see if you can sketch the graph of this function. You've got 4 points to plot. You should see that the swoopy shape, the ski slope looking swoop. It should be, I don't know, this camera sometimes reverses things, but as you head in the positive direction on what would be the x-axis, it should be swooping upwards. It won't be upside down like the other ones because there was no negative sign up here. So ultimately the graph should look like this, right? It's just that we'll have different values of these points because of the numbers that are coming out of the function, but that would be its overall shape. Okay, so that's more practice with these functions. Go grab that worksheet that's Exponential Functions Part 2. You will see a lot of practice with loading up these functions and calculating. And then the next part of this that you'll come back to is using these functions in scenarios other than just, making a graph or something like that.